Hi everyone, back to inspection testing. Now we're going to look at live testing. Do some live testing, see what sort of things we get. Very similar to a dead test, apart from a few more numbers in here, a few more results to consider. So to start with, we're going to look at protecting measures. So automatic disconnection of supply, ADS. So this is what we use for fault protection, and this basically says you've got a path that will disconnect any faults that you come across. So we get this by making sure everything's earthed, everything's bonded. And the way to test this is by doing an earth fault loop impedance test. So this will give us our ZE and ZS reading. This will say yes, it's earthed to a good standard, and yes, it will disconnect in the requirements of BS 7671. So if you go in BS 7671, there's the maximum values, the maximum impedance values that can safely disconnect within time. External earth fault loop impedance test. So this is just on a general circuit. So if it's an external test, we only want to consider our earth that's supplied by the electricity supplier, and we therefore only test a disconnected earthing conductor. The reason we do this, guys, if you've got your bonding conductors and your protected conductors, they provide a parallel path and could make us a really good reading that might not be there in a couple of years. So the easiest example is your water pipe coming into your house. It's copper, goes all the way into earth. If we include that with our bonding conductor, we'd get a really good earth path, and it'd say you've got a very low earth fault loop impedance reading. 2 years time, somebody comes and changes your water pipe for a plastic pipe, which they are upgrading to, that path's gone. We may have relied on that for our test reading, so therefore we said it's got brilliant earth, and in fact it hasn't, because it's been stolen from us, and therefore our main earth that we do have might not be good enough. So if we test our main earth, we know it's right, and that's what we're relying on. Earth fault loop impedance test when using earth electrode resistance. So the only time we do an earth electrode resistance test is when we've got a TT system, and therefore we have to connect to the disconnected earthing conductor, which goes down to the earth rod, and that provides the path. Again, we don't want any parallel paths through gas and water pipes. It's a very similar sort of question. This is a very similar sort of question, but a complete opposite in its own rights. So this, if you read the question carefully, it says earth fault loop impedance on a final circuit. So a final circuit could be a socket circuit or a lighting circuit. This sort of test is our ZS. So we've gone from the ZE test, which is your external, to ZS, which is your total. For this test, we need all the protected conductors connected, so all your bonding conductors, all your CPCs and your main earth. You'll probably find that this reading's very low. Some people even get a lower ZS than they do ZE because everything's connected and you've got a path there. So this test is your working condition test. So this is what sort of reading we'd expect in a normal working environment with everything connected. Test for PEFC and PSCC. So they're your prospective earth fault current and prospective short circuit current, carried out on a single phase installation with values 0.7 kiloamps and 1.2 kiloamps. So the important bit here is single phase. So in a single phase, we take the highest value, which would be 1.2. If it was three phase, we'd take the highest value and double it. So if that was three phase, we'd take 1.2, we'd double it, which gives us 2.4 kiloamps. You'll see that's one of the options there. Another one people sometimes get wrong, they add the two together, 0.7 plus 1.2 gives 1.9, which is also an option. So you've got four answers there that it could possibly be. So single phase, the highest reading. Which of the following tests would normally be carried out with test connections on the supply side of an installation's main switch? So the supply side, which is your incoming side of your main switch, you've got your meter tails coming in. We can do an external earth fault loop impedance test there. So that's testing the earth coming into the building. We can't do an RCD test because that's got to be on the outgoing side of an RCD, which is always after the main switch, so we're not that far along. We can't do an insulation resistance test because it has to be isolated, and we can't isolate something on the supply side of the main switch. Voltage drop. Voltage drop is where you take the voltage coming into the building and go to a point in the circuit and take the voltage there and see how much you've lost. We can't do this because the incoming point, so that is the voltage that we get, so there's no way it could drop. There's no circuit after that for it to drop, if that makes sense. 30 milliamp RCD for additional protection. So additional protection we put a test current through of 5 times the RCD is rated. So the RCD is rated at 30 milliamps. So 5 times 30 is 150. So we do 150 milliamps. So that's to see how fast it can trip out when there's a major fault, which a lot of the time it does happen like that. If there's a fault on an RCD, when it comes to an RCD, it's generally something that needs to disconnect straight away. That's why we do that test. Which of the following tests carried out in order to verify a protected device has a sufficiently rated braking capacity? So your braking capacity is on your MCB. A lot of the ones we use, guys, are 6 kiloamp and 10 kiloamps. And it's a prospective fault current that we test. So you do a prospective fault current test and it will say if the device is suitable. The protected device has to have a higher rated than what we test. So if your protected device is 6 kiloamps and we test and get 7 kiloamps, that device is not suitable. Which of the following tests would never be carried out with test connection on the supply side and installation main switch? So we covered this already in the previous question. The RCD, I said that test has to be done on the outgoing side of the RCD, otherwise you'd never trip it out. You'd be testing all day and it would never trip out, because that fault would not go through the RCD, it would just go through the main switch, so you're wasting your time. So back to PFC testers, prospective fault current, short-term PFC, and the readings that we get on a PFC tester are kiloamps, which is KA. So PFC tester set to KA, kiloamps. Back to what we've already mentioned, the braking capacity of a protected device has to exceed the prospective fault current, which is your IPF. So like I said before, if it's a 6 kiloamp rated MCB, you cannot have a fault current at 7 kiloamps going through it because it would get damaged. So you have to replace the MCB to a higher rating. When we talk about the rating of a MCB or protected device, it's not your normal 6 amp, 32 amp what the circuit requires. There's another reading on there and how much fault current it can safely take, which is where we get a 6 kiloamp and 10 kiloamps. 30 milliamp RCD for additional protection. So we've mentioned additional protection already. So when we do that test, it's got to disconnect within a certain time. The maximum time it's allowed to disconnect is 40 milliseconds. A very short period of time, so 0.04 seconds. Very quick, so instant click of a finger, it should turn itself off. Thanks for watching, guys. Again, any questions, drop me an email, dw.raw@mbro.ac.uk, and hopefully see you soon. Take care.